Optimization deals with creating a mathematical function to model a real-life situation, and then finding the maximum or the minimum of that function. You can imagine that a lot of companies would be looking to maximize their profit. So this is a type of math that happens often in the real world. You already know how to find the maximum or minimum of a quadratic function, so that part is going to be pretty easy. The tricky thing will be interpreting the context in order to figure out what the function actually is. We're going to start with revenue and sales type problems, so let's try one out. Suppose you are selling eggs from your chickens. Your base price for a carton of eggs is $3, and you usually sell 18 cartons per day at that price. You've experimented with raising and lowering the price in the past, and your data shows that for every dollar you increase the price, you lose 3 customers. So, what is the best price for a carton of eggs if you want to maximize your profit? Okay, so step 1 in these problems is always going to be creating a variable. So let's think about what we can change in this situation. Well, we have control over the price of the eggs. So, let X be the number of dollars that we increase the price. Step 2. What do we want to maximize? Well, it's the revenue from our egg business. It's how much money we're going to make. The formula for revenue is always sales times price. So that's the number of things that you sell times how much each one costs. So how many cartons of eggs will we sell? Well, if we don't change the price at all, it's 18. But for every dollar that we increase, we'll lose 3 customers. So sales is going to equal 18 minus 3 times X. And how much does 1 carton of eggs cost? If we don't change the price, it's $3. But we'll be changing the price by X dollars. So price will equal 3 plus X. So we put it together, and that means that revenue equals 18 minus 3X times 3 plus X. And you can go ahead and type that right into Desmos. Now we just find the maximum. So the max of this function is 1.5, 60.75. And that means we increase the price by $1.5 to get a maximum revenue of $60.75. So the optimal price for a carton of eggs in this scenario is 3 plus 1.5, which will come to $4.50. So let's try another one like this. In this problem, suppose you're selling scarves that you knit while watching Netflix. Every week, you sell 16 scarves for $15 each. A survey shows that for every $2 the price is increased, 4 customers won't buy a scarf. So what is the best price to sell your scarves at to maximize revenue? We're going to follow the same method as the previous problem, so if you want to tackle this one on your own first, feel free to pause the video. Okay, so step 1, decide on our variable. It's usually safe to just always say X is the number of dollars the price is increased. So step 2, what is the price then? So we have a base price of $15 plus X. Step 3 is how many we can sell. Well, if you lose 4 customers for every $2, then you lose 2 customers per dollar, yeah? So the amount you sell will be 16 minus 2X. Step 4, let's put it together. Revenue equals price times sales. So we have 15 plus X times 16 minus 2X. Step 5 is graph it. Well, this is interesting. We have a negative value for X. This means that it will actually be more profitable to lower your price in this case, to 15 minus 3.5, which is $11.50. This means that we are selling our scarves for less money each, but we're going to end up selling more scarves, and therefore, in this case, actually making more profit. In recap, if we're using a quadratic to solve a revenue optimization problem, first, we let X be the number of dollars that we increase the price. Then, we figure out how to write the new price in terms of X, and how to write the number of sales in terms of X as well. Then, all we have to do is find the maximum of the revenue function, which is going to be sales times price. And that's it.